Hello everyone and welcome to the CEM lesson number 8 homework recording. So we're going through homework today, but it's obviously in relation to lesson number 8, which is our maths homework. Let me show you the slides. So this is the homework we're going to talk about, the homework for week 4. Obviously it's the maths side of things, so we're using our quick practice test book for maths, and we'll be looking at tests 10, 11 and 12, 13 and 14. So a big chunk today, so we'll go through. Remember, obviously, as we're going through these, that the timing is still one of the main components we're testing. So hopefully, as you've been going through, you've been doing these tests to time to give yourself just a guideline of where you need to be. Even if you're not finishing the tests with a time limit, that's absolutely fine. You can always go back and then finish the tests. So if you are sitting here with some incomplete tests, I'd recommend actually going back, finishing them, having an attempt at all the questions, and then marking them. The reason we want you to start timing yourself is so you just get a sense of where you're at, what the goal needs to be. We're not necessarily expecting you to be right there instantly straight away. So if you aren't quite finishing the time, that's absolutely okay, as long as you know what you're working towards and we're taking steps to improve it. And again, things that can improve your times will be faster times tables, better methods, being a bit more efficient with the working out, only doing the working out that you really need to show rather than just working out for the sake of working out, because obviously that wastes time. And also prioritizing questions. It's really important. I know this happens a few times during the week where sort of I caught students, still on question 2. They've spent sort of 3 or 4 minutes on the question. They weren't making any progress, and they weren't going to because it was really hard. Whereas if they'd skipped on 3, 4, 5, 6 down the line, and then maybe come back to 2 later, they'd have made much more progress in the time, and actually they'd still had that question they were struggling with sort of percolating in the back of their heads, and they'd had a good shot at it at the end. So just prioritizing your questions is a really important skill and something I'd highly, highly recommend. Let's make a start. So to begin with, we have test 10. This is quite a nice short test, but a bit of a difficult one because it involved a few different components. Let's run through them. So we've been given 3 clock faces here. And again, if you can't see on my screen as clearly, remember you've got it in your book. So please do have your books out and please do be going through them with me. And it's only a 3-minute test this, so the time is really going to fly by. So we've got to be very efficient. And again, if we are sort of getting us a bit stuck, well, that's fine, but then jumping around and getting the questions we can do and coming back to those last ones, really important. So use the clocks below to help you answer the questions in this test. So the important thing is these clocks are showing the equivalent time. So the first thing I think I might do, because all these questions relate to time and to the time difference in these clocks, is I'm probably just going to work out what the difference in time is between the two of them. So for example, from New York and London, I can see in New York is 4, London is 6, so that's a difference of plus 6 or 6 hours. And then going from London to Hong Kong, that's going to be a difference of, from, if I can see clearly, 10 till 5. But of course, you remember that's 7 hours difference between the two. So just by pre-working it out, I think it might help me with these questions. Number 1, how many hours ahead is the time in Hong Kong and the time in New York? Well, you could do it in 2 steps. You go from New York to London or both, but I can see in total it's 15 hours. And whether you just work out the difference between 4 and 17 or 6 and 7, which is in 2 steps, it would actually work both ways. So the first answer going to be, oh sorry, hang on, no, 13 hours. Check your maths, Luke. 7 plus 3 again, 13. Number 2, when it is 4:52 in London, what time will it be in New York? Well, it's 6 hours different, but New York is 6 hours less. So I've got to take away 6 hours. And if I write it, that's going to be, because they've done it really nicely, they put it in the 24-hour version. I can just take away 6. And it's 10:52. Make my 10 look a bit more like a 10. There, 10:52. Question 3. The time in Zurich, which you've not heard about, is 1 hour ahead of the time in London. If it is 2:21 in Hong Kong, what is this in Zurich? Well, London would be 7 hours less, but Zurich is 1 hour ahead. So the difference between Hong Kong and Zurich would also be 6 hours, and Zurich is 6 hours less than Hong Kong. So again, I've got to take away 6 hours from here. It's going to be in 24-hour format, 0821. Neil goes to bed at 10 o'clock in New York and sleeps for 8 hours. What time in Hong Kong will it be? Well, first off, I'm going to work out what time it will be in New York 8 hours later. So if he goes to sleep at 10 o'clock, or there's a couple ways we do it. We could do 2200 Then add 8, well, that would be sort of 30. But you've got to remember, with a 24-hour clock, if you ever end up with a number that's over 24, take away 24, and that will then tell you the time of the next day. So it's actually going to be 6 o'clock the following day in New York. So now what it's really asking me is, if it's 6 o'clock in New York, what time is it in Hong Kong? And I know to get from New York to Hong Kong, I add 6, add 7, or add 13. And 13 add 6 will be 19. That's 7 o'clock. 7 o'clock in Hong Kong. Last question. A flight from New York to Hong Kong is 15 hours. If a flight leaves New York for Hong Kong at 10 past 7, what time will it be in London when it lands? Well, a flight leaves New York at 7 o'clock. 10 past 7. Then it's going to be a 15-hour flight. So that's going to be plus 15. So 15 plus 7 is going to be, think it through. Easiest way of doing it, I think, is to say 2200. And now this is still New York time, so I'm going to do NY to label it. And then all we have to do now is compare what that New York time that we've got will be to London time. And the difference from New York to London is 6 hours ahead, 6 hours in the future. So I add another 6. Same method as down here. That's going to be, oh sorry, be very careful, Luke. Don't. It's 7:10, so I can't forget that. So it's 22:10, which means this will be 28:10. And then if I take away my 24 hours, that will leave me with 0, 4, 10. So if I break up the steps, let's just go through it. I've just started with the New York time now. So this is all New York. And this is New York as the flight leaves. This is the 15 hours from the flight time. So we know it'll be the time in New York will be 15 hours later when they arrive. And I'm then just comparing that to the London time because it's just one step. And as I say, the difference is plus 6. So that step here is that plus 6. And then just comparing the 28:10, I suppose I should write it out because I didn't have the room very easily, but I can still fit it in. If we just take away 24 from 28, that actually leaves us with the 4:10 time that we ended up with. So that's where 4:10 comes from. Right, that's one test done, making some progress. Right, test 11, let's have a look. Cool questions. Right, so how much longer is, oh, that's the example. So a map is drawn on a scale of 1 to 250,000. So a quarter of a million. What is the actual distance represented by 2 centimeters? So the thing to know here is obviously the map scale is the small number and the real scale is the second number. So if the map scale is going to be 2 centimeters, that's twice as big. So this will be twice as big. So the answer would be 500,000. 1, 2, 3, 4, 5. But the thing to realize is whatever you put in, so if this is centimeters, this will be centimeters. And so whatever you put into a scale will come out. And obviously the clue here is it wants it in kilometers. So we've got to work out how to take our centimeters to kilometers. The first thing I'd do is I'd go from centimeters to meters. So if we do that, go from centimeters to meters is dividing by 100. That's the same as crossing off 2 zeros. So it's going to be 5,000 meters. And then from meters to kilometers is the same as crossing off 3 zeros, which is 5k, 5 kilometers, km. So that's the thing. If you put in centimeters, you get out centimeters. You put in meters, you get out meters, and so on and so forth. Just remember that with scales. Whatever you put in is what you get out. Right. Number 2. One angle in an isosceles triangle, so this is your isosceles triangle, is 102. Write down the measurement of another angle. Well, the reason we can work this out is because 2 facts. One, I know that all the angles add up to 180, but I also know that 2 of the sides have to be the same. So what I need is one of my angles to be 102. So this one here has to be the 102, because I couldn't have two angles at 102 because that would make it 204, which is bigger than 180. So my large angle has to be the 102. And so I now need two equal angles that are the same. So that's going to be half of what's left over. What's the difference between 102 and 180 is 78. And so if I divide that into 2, if I halve that, I'm going to find out what each of the angles are. And I'll just write that down one time. So the way I do this is half of 70 is 35. Half of 8 is 4. Put them together. The answer is 39. So each of my angles is 39 degrees. There's my answer. Right, next up, question 3. 5622 times 842 equals that large number. What is that large number plus, oh, well, so it's going to be an addition. Okay, well, we can write that. I think, what can we say? I've got it. Right, guys, be very careful of this. This is obviously because my scanning is not as clear. That is a divide sign. And on my screen there, it looked like an add. And I was going to say, there's no way adding 4 million and something would end up with an answer that's only 3 digits long. So I am always using, if they ever give you a guideline as to what the answer should be, use that to influence your decision. Because I was thinking, well, there's no way 4 million getting larger is going to fit in 3 spaces. So I had another check and actually looked at my copy of the question in front of me. And of course, it was a divide sign. So hopefully you've got your books out or you've got your questions out in front of you and you're using them to follow rather than the scannings, because they can just miss out on some of that finer detail. Right, this is a much better question, and now it explains as to why they gave me this info. So one thing to note, the fact that they've got 2244, if you do 5,622 and you times it by 2, you actually end up with 11,244. So we're dividing it by something that's twice as large. What that means, if I know that 5,600, sorry, get the pointer out, 5,622 times 841 gives you this answer. If I'm dividing it by something that's twice as large, my answer is going to be half of this. So my answer is actually going to be 421 without having to do any horrible complicated division, because I must say doing this one by long division is horrendous. And I think that's why they've given you this clue. Well, it definitely is. So let's just go over that again. So if, and I suppose here's the way to show it, 5622 multiplied by 842, that is going to be equal to this number, 11244. If this number, sorry, if the 11,000 is twice as big as the 5,600, and it is, well, it's going to be the same as this number multiplied by this one being halved. If you make this side bigger, I've got to make the other side smaller. So 4, 2, 1. And then I can also be sure that both of these work out as 4,700,000 724 for both sides. So 4733. And if you're not too sure about this, for this one, I'm more than happy that you get out a calculator, if you've got one, and you just test and just see if you understand. And perhaps an easier example would be something like, for example, if I had 10 times 6, and if I made this number twice as large, is equal to 20 times what? So if you had, this is much smaller numbers, obviously, and I picked those because hopefully they're a bit easier to spot. Well, 10 times 6 is going to be equal to 20 times 3. Both of them equals 60. If I work out 10 times 6 is 60, 20 times 3 is 60. But look, this number has gotten twice as large. So if I halve the other number, I keep my equation balanced, even. And that's what the same principle is going on here. Cool question. I like that one. Definitely a lot easier when you can actually see. You can see what they're asking though. Divide sign, not a plus. Right. Book A weighs 320 grams. Book B weighs 553, and book C, what's the total weight? All right, an addition. So I'm going to put them in order of height, that's how I like to do it, or size, sorry. 843 plus 453 plus 320. Again, good habits, keep everything in their columns. Plus sign. Right, 3 plus 3 plus 0 is 6. 4 plus 5 is 9. 9 plus 2 is 11, so carry the 1. 8 plus 4 is 12. Plus 13 is 15. Plus 1 is 16. Nothing plus 1 is 1. So 161. And just be clear, that's in grams. So to convert it to kilograms, divide by 1,000, 1.616. Although actually we just wrote in the numbers we had before, 1616. I think we'll get the answer. No problem. Next page, question 5. How many cubes with a 2 centimeter width can fit into a cube with an 8 centimeter width? My goodness, let's actually just sketch this out for me. So there's my big cube. If that's 8 centimeters, how many 2 centimeters can I fit? Well, I'm able to fit in 4 of them, because obviously 8 divided by 2 gives you 4. So my 4 spaces, and that's going to go up the sides as well, and along the back. So I'm going to be able to fit in 4 across the bottom. So you can say 1, 2, 3, 4. 4 across the top, 1, 2, 3, 4, and 4 going back, 1, 2, 3, 4. So to fill in this front grid, it's going to be 1, 2, like this. So that's 4 times 4, which is 16. And then going back, that number is going to, 16 is going to go back 4 times. So times another 4. So my answer is 4 times 4 times 4, which is going to be 16 times 4, which is going to be equal 64. So I think you would fit in 64 of those cubes. And again, my little sketch, just to show you, I've worked out how many cubes I could fit in one direction, then another, then a third. Obviously, because it's a cube, it's the same in all directions. If it was not a cube, but some sort of different 3D shape, which had longer, I might have to times it by a large number going backwards. But it's this grid, it's going to repeat itself 4 more times. So it's going to have here, 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 and here. You'll get that same pattern of 16 repeating, going backwards. Right, number 6. Make some space, just so I got the working out room. Right, you can always rewind the videos if you need to rewatch anything, or pause at an appropriate time. Right, number 6. 175,000 people live in town R. 45% are men, and the rest are women. 50% of the women are married. How many of the women in town are unmarried? So we don't have to worry about the men. The rest being women mean there are 55% are women. And then of that 55%, half are married. So if half are married, half won't be. So let's just work out what half of 55 is. The way I would work out half of 55 is I would do half of 50, which is 25, then half of 5, which is 2.5, add them together, and I'm going to have 27.5. So that's as a percentage. So that's your first bit. So let me just say 27% both are married and aren't married. But now I need to now work out 27.5% of this big number here, 175,000. The way to do these percentages, I think, as much as I've shown you guys before, is to split it up into much easier ones. So instead of working out 27.5 in one go, I'm going to work out what 20% is. And I'll do that probably by working out 10% and doubling it. So maybe I should add that in. So I'm going to work out what 10% is. And from the 10%, I will double it to get to 20. From the 10%, I'll halve that answer to work out what 5% is. I'll work out what 1% is, probably by dividing by 100, and then I'm going to work out by 0.5%, but the way I will do that is I'll halve whatever my answer is. So these are the first two that I'm going to work out, so hopefully you can see. 10% and 1% are where I'm going to start, and I'll use those answers to work out the other percentages, and then I'll just add the appropriate number of answers together. So I'm going to do a little star, because these are kind of my most important ones. These are the ones that are easy to do, and will give me the other answers. So as I know, 10% of anything is just to divide by 10, so that's the same as crossing off a 0. So I'm going to have 17500, so that's 17,500. And then 1% is to work out 1% of something, we divide by 100. That's the same as crossing off two zeros. So I'm going to have 1750, 1,750. So now, how can I work out 20%? Well, it's going to be just from here to here, twice as much. So all I need to do to work out 20% is do 17500 times by 2. And again, I don't mind how you do this. You might do it in your head. You might write it down. For me, I'm probably going to do, I might do the 500 added together is going to be 1,000. And then, well, actually, I tell you what, this might be the way I'd set this one out, just for my own ease. Times by 2 is the same as adding it together twice. So I'm just going to do 0, 0, carry the 1. 17 plus 17 is 14, plus 1 is 15. There. 35,000. Quite quick. Let's do a quick logic check. Does that look twice as big? Yes, it does. I need to now work out 5%. How can I do that? Well, I think the easiest way is just to halve 10%. So again, halve, maybe you decide to use your bus stop. 17500. So 2's into 1 don't go. 2's into 17, 16 goes in 8 times. Remainder 1. 2's into 15 goes in 7 times. Remainder 1. 10, 5, 0. So my answer, 8750. And then, last one, to work out my half a percent. Oh dear, it's hard to pick. To work out my half a percent, I'm going to need to do half of 1,700. And maybe I'll do this differently. Maybe I'll do this in my head and I'll say half of 1,000 is 500. And half of 700 is 350. And half of 50 is 25. I'll add these together. So I'll have 5, 7, 8. So now I've got my building blocks. I just need to work out how many of each building block I need. So I am going to rub these out now. Hopefully they made sense when I did them. And let's just do a big old addition. So to get to 27.5%, I'm going to want 120. I want 15. I want 2 1%, and I want 0.5%. So one of those, because 20 plus 5 plus 1 plus 1 plus 0.5 gets me there. So actually 10%, although I don't actually need it now, it was just useful. So I want 135,000. Maybe I'll move it up just so I've got some more room. And to that 35,000, I'm going to add an 8,750. So there's my 20%. There's my 5%. I'm going to need the two 1%, so I might actually pre-times that together. So 1,750, so double 1,750. Going to be 0, carry the 1, 15, carry 3. So it's going to be another. So I'm going to add 2%, because that's two of those added together. That's what I just worked out here for 3,500. And my 0.5%, which is 875. And now I just need to add them up. For this, I might just scroll down a bit. I might ignore the black line. That's just there. And really quickly, got 0, 0. That should be a 0. Be careful how you draw them. 0, 0, 0 plus 5 is 5. We've got 0 plus 5 plus 7. So that's going to be carry the 1. We've got 7 plus 5 plus 1. So actually, I'm going to do 8 plus 8 is 16. Plus 5 is 21. 2, 1. And here I've got 8 plus the 2 to give me to 10, 10 plus 5 to give me 15, 15 plus 3 to give me to 18, so 1 carry the 8. And I've got 3 plus 1, 4. So my final answer, 48,125 unmarried women. Whew, quite a big question, that one. But I think that's about as fast as you could do it. Hey guys, the working is there if you need it, but I'm going to get rid of that now. You can always rewind the video, remember. But I will just need the room to go to the next question. And again, guys, tough to do that in 4 minutes. No question. So that one might be something I leave for the end just because it looked like it had a lot of steps. Let's go through. What is the time 4 1/6 hours before 2:07? So I know what 4 hours is, but I'm going to have to work out for myself what will 1/6 of an hour be in minutes. So remember, it's not 1/6 of 100, it's 1/6 of, in minutes, it's going to be 1/6 of 60. Well, again, we times by the top, or 1 times 60 is 60, divide by the bottom, that's going to be 60 divided by 6, which is 10. So what they're actually saying is 4 hours and 10 minutes earlier. So what time is 4 hours and 10 minutes before 2:07? So if we go back, we just take away, so obviously if we take away 2 hours, that will get us back to 0, 0 and 7. Take away another 2 hours, that will go back from the top of the clock, so obviously 24 and 0, 0 are the same, so it's going to be 22 and 0, 7. And then don't forget my 10 minutes, that's going to then go down to 22, 0, 0 and have 3 additional minutes left over, so we're going to be 3 minutes earlier, so that becomes 21. Bring its minutes, so it's going to go 57. So 2157. Tough question. I think this part might trip a few people up, which is actually what is 1/6 of an hour. But again, sure, it's 1/6 of the minutes. 60 minutes gives you 10 minutes. And then we just take away 4 hours and then take away 10 minutes. And I recommend doing it in 2 steps. And so you can see the jumps I made to get from 0 to 07. So I just did it in jumps. That was minus 2 hours. That was minus 2 hours. And that was minus 10 minutes. And I did that just so I could focus on making no mistakes. Right, number 8. A numerator of a fraction. What is a numerator? It's going to be the number on top. You've got the numerator and the denominator. The denominator on the bottom, also called the divisor. So the numerator of a fraction is 12 less than the denominator. The fraction is equivalent to 1/5. So I'm actually going to start with my 1/5. And we need the difference to be 12. Well, obviously, the difference currently is 4. So let's try again. I'm going to just do equivalent fraction, times it by 2, times them both by 2, because that's how my fractions work. So I think this one to me smacks something that I think is just as much as I'm going to be efficient to do in terms of trial and error. So 2 out of 10, what's the difference? The difference is 8. Let's go to 4 out of 20. So again, I'm just doubling each time. What's the difference? The difference is going to be 16. So I need something smaller. So maybe I want to do 1, 2, 4 was too big. So let's try 3. What would have to be to keep it equivalent? 1 times 3, 5 times 3 is 15. What's the difference? 3 and 15. Oh, the difference is 12. So my fraction is 3/15. What is the numerator? The numerator of that fraction is 3. As this one was just a trial and error, I just tried a few equivalent fractions until I got close. I knew once I had gone past it, so once the difference was 16, it meant my fraction was too big. So I knew, again, if 2/10 was too small, and 4/20 was too big, 3/15. Bear in mind all these are equivalent, they're all the same. Must be the answer. Right, test 12. How many more factors does 48 have than 24? For these, I'm just do some factor bugs. Again, you could also just list out the factors. I like factor bugs though because it looks nice. So remember, they always come in pairs. So first example might be 1 and 24. Then can I divide 24 by 2? Yes, I can. It'll be 2 and 12. Can I divide it by 3? Yes, I can. It'll be 3 and 8. Can I divide by 4? Yes, I can. It's going to be 4 and 16. Can I divide by 5? No, I can't. Can I divide by 6? Yes, I can. It's going to be 6 and... Oh, did I say 4 and 16? I meant 4 and 6. And funnily enough, then, that means we finished. So let me just do that again. Sorry, 4 and 16. 4 and 6. And now I said, ask myself, can I do 5? Nope. Can I do 6? Well, yes, I've already done 6. And that's how you know your factor bug is complete. Once you've counted up from 1, 2, 3, 4, 5, 6, and you've got to a number that's already been used, you know it's completed. So that's 1, 2, 3, 4, 8. 24 has 8 factors. Let's do 48. So I've got 148. I've got 2 and 24. I've got 3 and 16. I've got 4 and 12. That's my 12 times table. Do I have 5? No, I don't. Do I have 6? Yes, I do. 6 will go in 8 times. Do I have 7? No, I don't. Do I have 8? Again, look, I've asked myself, I've got around to the other side. That means I've finished. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are my answers. The answer is 2 more because it's asking for the difference. How much liquid is in the container to the right? So if this is 1 litre is here. So each spacing, 1, 2, 3 is a third of a litre. We've got 1, 2, 3. You've got 2 litres. Because we end up doing twice as much. So that's every 3 divisions is 1 litre. There's another 3 divisions. So that's going to be, excuse me, 2 litres. Right, calculate 2 1/3 minus 1 4/5. So there's a couple ways of doing this. I'll rewrite it just to make it a bit clearer because it's a bit blurry. That's 1 4/5. So I think for this one, I'm probably going to separate my whole numbers and my fractions and go from there. So obviously, 2 minus 1 is going to leave you with 1. And we've got a third minus 4/5. To do any addition or subtraction of fractions, you need to make the denominator the same. So let's do that now. So I'm going to rewrite this where the denominator is the same. To make the denominator the bottom the same, I'm going to do 3 times 5 and 5 times 3. Because I know they're both in the same times tables because I've used both numbers. To work out what has to go on top, well, in order to turn this 3 into a 15, I have to times it by 5. So I've got to times the 1 by 5. And in order to turn this 5 into a 15, I times it by 3, so I've got to change the top. So 4 times 3 is 12. So now, he wants to know 5/15 minus 12/15. So be careful here, it's going to lead with a negative number because I've got a 5 take away 12. So it's going to leave me with minus the difference, which is minus 7. So currently, what have I got left over? Well, I've got 2 minus 1, which gave me 1, and my fractions gave me minus 17. So let's put those together. So now the last part needs to be 1 minus 7/15. And I can actually work this out by saying, okay, well, 1 is the same as 15 out of 15 minus 7 out of 15. And 15 minus 7 is going to leave me with 8/15. Just quickly check, can I simplify 8/15? No, I can't. So my answer is 8/15. So again, just to recap what I've done, separate the whole numbers. So do it in 2 steps, work out what's left over as the whole numbers, work out what's left as the fractions, and then these are my 2 answers. And so all it is combining those together, in this case negatively, because this is still a negative number, so taking away from each other and getting your final answer, your final answer. If you don't like this method, one thing that you could do, I won't run through it now, but you could make them top-heavy fractions and then take them away from each other using a similar method, using similar denominators, and you'd get the same answer as well. I don't mind. Oh, sorry, number 4. Let's not move on till we're done. What is the next term in the sequence? So let's see if I can work it out. Let's find out if there's a consistent pattern each time. So we've got 74, 68, 70. So it seems to be going up and down. Maybe there's 2 patterns going on. So let's have a look. So this is 74 to 70. If ever it goes up and down, I normally think there's 2 things going on. So I'm going to skip one and see. So 74 minus 4 is 70, minus 4 is 66, minus 4 I think would be 62. And then that means at the bottom, again, this is going to be going up by 4. So we've got 78. Oh yeah, definitely. If we look, this one's also decreasing, but it's decreasing from a different number. But for us, our answer, 62. Just to be clear, what's the pattern? Every other number goes down by minus 4. And not that we need it, but this one's also going down by minus 4, but on different numbers. So 68, 64, 60. So the next one would be 58. Okay, there's my answer, 62. Right, next question. Which equation correctly describes the relationship between A and B? So let's compare. So from 7 to 11 is going to be how much bigger? Plus 4. It's going to be plus 1. It's going to be plus 5. So it's not as simple as that, sadly. What a shame. So B can't just be plus 4. So it's not that one because it doesn't work for these 2. Could it be B? And okay, so this one I'm using elimination because I think I'm just applying it. So 2 times A would be 2 times 7, which is 14 minus 3. It works for that one. For this one, 2 times 4 is 8 minus 3 gives you 5. That works for that one. So B currently is looking good. Then we've got 8 times 2, which is 16 minus 3. Yeah, so actually I think B works. We can just check. Does that one work? No. Does that one work? Not for all of them. Which one doesn't it not work for? Well, what's 3 times 4? That's going to be 12 minus 11 doesn't equal 5. So because they've given you the formula, you can just use them by substituting in the values of A and B and seeing what answers. So just to be clear, how did I substitute it in? Let's do this first example. I said, instead of B, I had 11. So it should be 11 equals 2 times A, which in this example is 7, minus 3. And I asked myself, is that true? Yes, it was. Then I did, okay, well, how about 5 being equal to 2 times A, and now A is 4? Is that true? Yes, it was. And of course, it was true for the other one, so I might as well finish it off. Was 13 equals to 2 times 8 minus 3? If you complete it, 16 minus 3, 13. Yes, it was. So that's the process I'm doing. Six, the net below forms a cube when folded. When folded, which face of the cube will not be adjacent to face B? Which one won't be next to it? Well, using our pairs, I know that face W won't be next to it. That was nice and easy because we practiced our cubes and nets. Question 7. The distance between town A and B is 3.46 kilometers to 2 decimal places. What's the maximum possible distance to the nearest meter? Okay. So 3.46 kilometers. Now, to the nearest 2 decimal places means this is the number that's been rounded up. So I'm going to ask myself, since it wants to know what's the biggest possible distance, what is the going to be? I need to know what numbers could round up to make 3469. Sorry, 346. So let me show you. So if I had 3.4649, for example, and I rounded it up to the nearest two decimal places, hopefully you can see that because this number here is not a 5, it would still round to 3.46. Simply if I went the other way, not that we're going to use it in this case, but I could say 3.455, whatever decimals you want. Both of these answers would round up to give me 3.46, but obviously look, there's a difference in size between them. If we're looking for the biggest, I want this one on top. And so now I'm going to say, if I convert it to meters, it would be 3, this number value is in kilometers, it's going to be 3, 4, 6, 4. It's going to be the 0.9, but we don't want to know which is the nearest meter, so we actually don't need that. Because if you look, this number here will still, if I ask you to round it to the nearest 10 in this case, because it's meters now, rounding that would give you 3460, which is the same value here. Whereas if I made that number 1 bigger, 3465, what would that round to now to the nearest 10? Well, now it would round to 3470. And that obviously doesn't work. So this 4 is as big as a number can get without making it round up to the next highest number. So this is our answer. And so 3464A is my answer. Tough question. It's about understanding not just how to round, but what the rounding actually means. And so remember, rounding is taking numbers, exact numbers, and obviously adding in some error, some mistake to make it simpler, simplifying the numbers. So I'll get rid of the 0.9 for now because you didn't actually need it. But of course, if we added more numbers, it would be 99999 because we want to get it as close to 4 as possible without actually becoming 5. And hopefully you can see that both of these would go in, but when we don't need this lowercase one because that's too small and it's asking for the biggest possible number. So that's the largest possible number that would be rounded and still end up at 346. Question 8. 4 camels eat 250 nuts a day. How many do 8 camels eat in 2 weeks? Okay, so it's going to be 250. That's what the 4 camels ate. But we want 8 camels, so it's going to be twice as much. But also that's per day, and we want to know per 2 weeks. In 2 weeks is 14 days. So maths is going to be this. So I'll do the first bit first. That's going to be the same as saying 500, that's 250 times 2 times 14. And I would do this probably by splitting up. So I want to do 500 times 10, which is 5,000. I want to do 4 times 500, which is 2,000. Add them together. 7,000 is my answer. But again, however you do your multiplication, I don't mind. Whatever method works best for you is the best. Sam weighs 32.5 kilograms. Daniel is 10% lighter. What's their mean weight? Oh my goodness. Right, so we've got 32.5. And how much is Daniel? Daniel is 10% lighter, so what is 10%? It's going to be 3.25 kilograms. And if he's that much lighter, I'm going to need to do 32.5. Let's write it, keeping it nice, so 32.5. Take them away from each other. I'm going to end up with 25, 29. What else do we have to think about? Now, okay, the mean weight is going to be, to work out the mean, add them together, divide by 2. So add them together, I've got 75, We've got carry the 1, that's going to become 11. So 61.75. Final step, 61.75 divided by 2. 2's into 6 go 3 times. 2's into 1 don't go, carry the 1, add the decimal. 2's into 17 go 8 times, remainder 1. 2's into 15 go 7 times, remainder 1. 2's into 10 go 5 times. So 30.875 is my answer. To 2 decimal places though, so the rounding, that's the number, that's my second decimal place, so that's what I'm rounding to. The number to the right of it decides, is it bigger or less than 5? In this case it is 5, which means the 7 rounds up. So 30.88 kilograms is my answer. So the answer is D. Right, have we got any more questions? No, we finished. Hooray. Well done, guys and girls. Give yourself a score out of 9. Some of these were tough, I think. Some of these were quite a bit longer, quite a bit more involved. Okay, guys, I've shown you the long form working out. There might have been a couple of shortcuts that you might have found, which is fantastic if you did. But if not, not to worry. Just keep working at it and keep practicing those mental skills to really up your pace. We got nearly there, guys. We just got test 13 and test 14. And test 14 is quite a nice small one, so you're doing really well. Test 13. Question 1. A total of 808 members attend a conference. The ratio of male to female, so M to F, is 3 to 5. How many more females attended the conference than males? Okay, well, first thing, the total is 808. How many groups am I going to split that into? Well, the total number is going to be 3 plus 5. So I'm going to split this into 8 sections. So let's do 8 divided into 808. 8 and 8 go 1. 8 into 0 go 0. 8 into 8 go 1. So that means each one of these numbers, one part, one share, is equal to 101 people. The males had 3 shares, so the males had 3 times 101, which is 303. And the females had 5 shares, and so they've got 5 lots of 101, which is 505. And let's just do a quick mental check. If we add these together, if I've successfully split 808, when I add them together, it should make the same number. 3 plus 5 is 8. 5, yeah, so 808 has been split properly because they add up together to make it. So then how many more females? What's the difference? Well, that's going to be 505. Take away 303. Which is going to be 202. Final answer. Question 2. TRE is an isosceles angle. So let's do isosceles again. So TRE. If this angle here is 96, what's the size of angle R? Bit of a thing on, again, the TRE is a bit of a distractor. The important thing to realize is, why did I make T the one at the top? Because in an isosceles triangle, you can't, 2 of the angles are the same. So I knew that obviously one of the angles had to be 96, but the other ones can't be also larger than 90 because all my angles in a triangle, as we've mentioned before, have to add up to 180. So now what I'm looking for is 2 angles. These 2 here are actually the same. And so we can work that out by doing 180 take away 96, which leaves you with 84. But then both of these angles then have to add up to 84, but they're the same. So half of 84 means each of these angles is 42. Final answer, 42. And if we were to just check it, 42 plus 42 plus 96 should add up to 180. Of course, these are the only numbers that will. And it does. Woohoo! Tick. 3 students took a test. sorry, 4 students took a test and the average score was 34. So 4 students got, 2 of the students got 36. Oh, great question. Right, so I'm actually going to list out the scores. So we had 36, 36, and 40. And the average was 34, which means this score here must be lower than these to pull the average down. And we had 4 students. So 4 times 34, because if their average is 34, if I do 4 times, I'll work out the total. So 4 times 34 is going to be 4 times 3, which is 12. 4 times 4, which is 16, but it's 120 plus 16, so it's going to be 136. So that was their total number of marks. And now, to find out the missing score, I can just do 136, take away the scores that they gave me. So I'll do it in my head. 136 take away one of the 36 is 100. 100 take away 40 is 60. So I've used up that one now, used up that one. So take away one more 36. 60 take away 36. I'm going to do 60 take away 30, which is 30. And 30 take away 6, which is 24. So the missing score is 24. There we go. So the key bit of understanding, I think, is this bit, which is that if 4 students got an average score of 34, to work out the total number of marks, I do 4 times 34. And I can just take away the rest. Question 4. There are 4 tomatoes, 6 oranges, and 5 bananas in a bag. Alicia picks out a tomato but doesn't replace it. Okay. She then picks out one more item at random. Right, so first off, she's taken out a tomato. So now there are 3 tomatoes, 6 oranges, and 5 bananas. What's the probability of getting a banana? Well, it's 5 out of how many? It's not going to be out of 4 plus 6 plus 5 because we've actually lost a tomato. It's going to be out of the 3 tomatoes that are left because she's not replaced it. The 6 oranges that are left and 5. So if I do 3 plus 6 plus 5, that's how much fruit is left, which is 9 plus 5, which is 14. So the odds of getting a banana is the 5 bananas out of the 14 bits of fruit that are left. And actually, we've worked out now the odds of all of them. But that's the one we were after. 5 out of 14 for a banana. What are the odds of a tomato? It would be 3 out of 14. What are the odds of getting an orange? It would be 6 out of 14. Yes, that makes sense to me. Right. How many different ways are there to arrange 3 books in a row on a shelf? Well, there's going to be 3 books, so it could be book 1, book 2, book 3. And actually, you could work this out yourself. So 1, 2, 3. Let me swap these 2 around. So it'll be 1, 3, 2. Or we could then swap these 2 around. So it'll be 2, 1, 3. Or we can end up swapping these 2 around. So keeping the 2 in the middle. And then 3, 2, 1. And so what haven't we shared together? What haven't we moved around? Let's have a look. We've done, so 1, 1. We can have there's another way we can have 1 in the middle. So we can have, instead of this way around, we can have 3, 1, 2. So 1, 1, 1, 1. We can have another 1 on the outside. So let's keep going. Move over a bit. So 1, 1, 1, 1. We can have another 1 out here. But to make it different for this one, we need to have 2, 3. And what I'm doing is I'm just checking. So I've got a 2 in the middle, 2 in the middle. 3 on the outside, 3 on the outside. 2 on the outside, 2 on the outside. So 1, 2, 3, 4, 5, 6. Any other options that I can see? I don't think so. Nope, I think I'm done. So the answer is 6. That's my answer. Now, that was trial and error. That was just checking by making sure there's no other possible options. Again, by fixing something in place, I know there's only 2 other ways it can happen. So if my 1s are here, so if my 1s are on the left-hand side and I fix them, there's only 2 possible options. So all I did is I checked that I had done both options with my 1 on the left both options with my 1 on the middle and both options with my 1 on the right. And I know I'd finished because that would have resulted in, look, 1 3 or two threes on the outside, 2 3s in the middle, and 2 2s on the left. Another one we got 2 2s in the middle, another one we got 2 2s on the right, another one we got 2 2s on the outside. So we know we're finished. Similarly, however, and this is perhaps slightly faster, you can also do 3 times 2 times 1. Whatever that answer is will always give you the number of arrangements. So if there were 4 books and you did 4 times 3 times 2 times 1, you can test this out at home. That will also give you the number of arrangements you can have. So in this case, if it was 4 books, it would be 12 times 2, 24. So you can see how the number of possible arrangements go up really quickly each time. But anyway, cool little fact for this one. I think it's quick enough that you can do that, or if you know the trick, multiply all the numbers together. Question 6. According to this train timetable, how long does it take to travel from Trevold to Provold if the 5:57 train is taken? Okay, let's just mark it on because those names sound familiar. So Trevold is here, to Provold is here, and if you get on the 5:57 train, you arrive at Provold at 6:34. So the difference between the times is 7:57 and 5:57 and 6:34. So the way I like to do these in my mind is I always ask myself, okay, well, how many minutes to get to the hour? So from here to here is 3 minutes. And from here to here is 34. It's not a very good 3. Let me clean that up. And the difference then is going to be 3 plus 34, which is going to be a total of 37 minutes. Question number 7. The internal angles of a pentagon. Pentagon is a 5-sided shape. Are 92, 45, 110, and 136. What's the missing angle? Well, the rule of pentagons is that you have to work out what the interior angles are, and the way I like to remember it is, remember, a triangle is 180. Any 4-sided shape is 180 is 2 180s, because if you look, it's made up of 2 triangles, so it's going to be 360. Any then 5-sided shape, if you look, is going to be made up of 3 triangles, so it's going to be add another 180, it's 540, and so on. If you want to do a 6-sided shape, not that we need it for this question, but it would be 4 triangles, so you'd add another 180, and so on and so on. That's a great way of working out if you can't remember how many angles are the interior angles of a shape. Just start at start at a 3-sided shape, which is always a triangle, and add 180 each time. You'll get there. So we need, in this case, it's a pentagon, so we need all of our numbers to add up to 540. So actually, I'm just going to clear out some room and start taking away. So I need to know my total. So let's do 136, add 110, add 92, add 45. Whatever that answer is, I'm going to take it away from 540. Let's go through. So we've got 6 plus 2 plus 5. That's going to be 6 plus 5, which is 11, plus 2, which is 13. We've then got 3 plus 1 plus 9, so 9 and 1 is 10, plus 3 is 13, plus 4 is 17, plus 1 is 18. And we've got 1 plus 1 plus 1 is 3. So 383, but that's my total angles I've got. I'm going to take that away now from my 540. So that was my plus, this is my minus. So 3, 8, 3. Can't do 0 take away 3, so I borrow. That becomes a 3. Becomes a 10. 10 take away 3 is 7. We've then got to borrow from the hundreds, so that becomes 4. Becomes 130. 130 take away 80 is going to be 50. And then 400 take away 300 is 100. So 157 is the angle that's left. Okay, guys, that's a fact. You might just want to learn all the interior angles of all the shapes up to, I think, probably about an octagon is as far as I'd go, as well as the trick I obviously showed you with 180 additional each time. Right, last couple, 8, 9, and 10. So 4 boxes and 3 drums costs £9.90. And then 3 boxes and 2 drums cost £7. Oh, that's a cool question. So 4 lots of B plus 3 lots of D equals £9.90. And also 3 lots of B plus 2 lots of D equals £7. So now, if I look at my two equations and I ask myself, what's the difference between them, which is another way of saying of taking away, so I take away the bottom row from the top, the difference between these two is 1b, between these two is 1d, and the difference between the value of £7 and £9.90 is £2.90. Now if I read what I've written now as my equation, 1b, one lot of b, and 1d equals £2.90. So the cost of 1b and 1d is £2.90. So you can look at this equation like we've done it with some maths. All I've done is I've taken away, but I've kept each column as its own thing. So 4 take away 3 is 4b, take away 3b is 1b, 3d take away 2d is 1d, and the values, the numbers are as they are. So £9.90 take away £7 equals £2.90. And it's just understanding what that means. Cost of 1b and 1d, £2.90. Number 9, subtract the smallest square number from the largest prime number in the list of numbers below. All right, well, let's look for the smallest square numbers. So my square numbers are obviously numbers that multiply together. Well, I can see 25. What's the next smallest? Is there a 16 in there? That's 4 times 4, or 3 times 3, which is 9. Can I see one? So obviously 5 times 5 is 25. Can't see anything else. No smaller square numbers. So now what's the largest prime number? Remember, prime numbers can only be divisible by themselves and 1. So I can get rid of immediately any even numbers. So nope, that's a multiple of 5. Nope, nope, nope. Could be 43, can't be 18, can't be 96, can't be 47, could be 17. Let me just double check in my head. Can it be 59? Do I think that ends up in 59? I don't think so. Which means my final answer then is going to be 59 take away 25. 9 take away 5 is 4. 5 take away 2 is 3. 34. So 59 was my largest prime number. I couldn't think of anything that that multiplied to give 59, nor can I think of any number I could divide 59 by and get a whole number answer. Right, last question, number 10. Figure 1 is made of identical cubes. Each cube has a length of 2 centimeters, so each one of these little lengths here is 2 centimeters. What's its volume? Okay, well, I'm going to work out the volume of each one cube, and then times it by the number of cubes. So the volume is going to be 2 times 2 times 2, because that's the base times the width times the height. So each one cube is 8 centimeters cubed. And now I'm just going to count them. 1, 2, 3, 4, 5, 6, 7, 8. That'll be the same on this side, so all these will be 16. Then in the middle I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that will be 12 plus 16, which is going to be 28 cubes in total. So now I need to do my 8 centimeters squared, so 8 centimeters cubed, multiplied by 28. That's how many of them there are. A couple ways of doing that. I think probably the best is to do 8 times 8 and 8 times 20. And add the numbers together. So 8 times 8 is 64. Pointer's not going so well. 8 times 8 is 64. And then 8 times 20, well, that's going to be 8 times 2, which is 16, times 10, 160. So 64 plus 160 gives me an answer 224. And actually I can see from the answers, that's the only one that's even close to being large enough. That's my answer. So again, guys, gives us a score out of 10. Well done. We're on to the last page, which is a nice short one, test 14. And then you're done. So really well done. You've worked really hard today. If you kept up with me, this has been a long video now. I'm sure we're going to be shooting at more than an hour now, which is quite tough to go through. What is the range of temperatures excluding Algiers and Moscow? So there's Moscow and there's Algiers, which you don't know. So range is the biggest, take away the smallest. So the biggest is 25 and the smallest is -9. So just be careful of this one. The range is going to be 25 minus -9. And that's going to be the same as saying 25 plus 9. So the answer is 34. Let me see if I can explain that another way. The range, remember, is the difference. So if I've got my thermometer, and up here I've got the hottest temperature, which is 24, and down here I've got -9, and somewhere about here I've got 0. What's the difference in temperature? Well, the difference from here to here, from 25 to 0, is 25, and the difference from 0 to -9 is 9. And it's saying what's the difference? The total difference is 25 plus 9, which is why my answer is 34. That's question 1. How many degrees warmer was Cairo than Moscow? So here we've got Cairo is 12 and Moscow is -7. So again, it's what's the difference between, here's my thermometer, what's the difference between 12 and -7? So same thing, for here it would be about 0. To get this gap will be 12, this gap will be 7, so the difference is 19. So far so good. What's the mean temperature of Moscow, Oslo and Atlanta? So Moscow, -7, Oslo, -9, and Atlanta, -2. So remember the rules of the mean. I'm going to rub this out here just so I've got some room. The mean is you add them all up, so -7 plus -9 plus -2. So it's really important to remember your rules. For me, whenever I see plus minus, in fact I might as well show it to you here, a positive add a positive equals a positive. A negative take away a negative equals a positive, which we saw earlier. It's here, minus and a minus. However, a positive and a negative, or a negative and a positive, both are the same as a minus. So if I was to use this little grid, and this is something that's definitely worth memorizing, to replace these numbers, I would have -7, -9, -2. I start at -7, I go down by another -9. That's going to leave me at minus 16. And then minus another 2. That's going to leave me at another -18. So the total temperature is -18, but I have to do -18 divided by the number there are, because that's how the mean is, divided by 3, which means the mean temperature is -18 divided by 3, which is -6. Now, if you've not done your negative number rules, this is going to be a really difficult one, but it's definitely a great sort of challenge to sort of think through. The example I often use is imagine you had a bathtub and you took out or added in hot or cold water. And if you imagine the hot or cold water as being positive and negative, it makes sense. Let me just quickly show you. Let me show you on here. Let me talk you through it. So if we added hot water, the overall effect would be the bath gets hotter. If we took away cold water, if we minus the minus, if we took away the cold, the overall effect would also be hot. You took out the cold water. If we took away the hot water, it would make it colder. That's why a plus and a minus is minus. Or if we added cold water, it would make the bath get less hot. So I like to think of it, and again, sort of, it doesn't have to be a bath, it could be a cup of tea. or even a bank balance. If we took away, so if we added hot, the effect is to get hot. If we took away cold, the effect is plus. If we minused positive, or we added a negative, the overall effect is minus. This is super worth learning, guys. I'm just thinking about. But again, any more questions on that? If you've not covered this, brilliant thing for us to go through maybe in a Q&A together. Sorry, I didn't write down my answer, or I didn't write down the right place. -6. That's better. Right, last couple. Last two. Done really well. The nighttime temperature in Cape Town was 40% less than the daytime. Okay, so Cape Town is 25. So it's going to be minus 40%. I'm going to work out 40% by working out 10%. That's going to be 25 divided by 10, which is 2.5. So if 10% is 2.5, 40 will be 4 times bigger. 2.5 times 4 is the same as doubling, so 2.5 doubled is 5, 5 doubled is 10, so 40% is 10, so it's minus 40%, so it's going to be 25 minus 10, which is 15, so it's 15 degrees. Final question. The mode temperature is 12. Mode is the most common. The mode is the most. What is the temperature in Algiers? Well, since we've got 3, 7, -7, they're different. -2, we do have a 12, which means if in Algiers was 12 as well, we would have 2 places with the same temperature. And since mode is the most frequent, that means we know Algiers must be the same as something else. And since 12 is the number that comes up multiple times, Algiers has to be 12. Because no other number came up more than once. That's my answer. Right, guys, we finished. Brilliant. Thank you so much for that. Give us your scores, please. Again, any questions, anything you're not sure of, remember you can, of course, rewatch the video, but also there are answers in the back of the book that you can use to support you, which will go through very similar explanations to what I've done, but it might be slightly different in terms of how they're laid out, and that can often help. Or if you still want me to go through things, please, please, please do come to the Q&A. Right, guys, brilliant. Have a wonderful week. Thank you so much for stopping by. See you soon.